you have a legacy monolith. It survived 5 years, 3 rewrites, and that never shipped, and 2 architects who left the company. Manual refactoring is slow, risky, and everybody is afraid to touch the code. In this video, I am going to show you 7 microservices patterns and how I use Claude Code to automate the most painful parts for each one. Dependency mapping, schema translation, routing generation, and FastAPI is the target. Let's go! Here's the map. 7 patterns, 1 migration journey. Pattern 1. Strangler Fig. You wrap the monolith, redirect traffic to the new FastAPI services, and strangle it one module at a time. Pattern 2. API Gateway Facade. One entry point in front of the system while migration is in flight. Pattern 3. The Sidecar. Cross-cutting concerns, logging, authentication, rate limiting, extracted out of the core service and into a proxy that runs alongside it. Pattern 4. Schema-First Pydantic. Every service boundary enforced by strict Pydantic model. No implicit contracts, no surprise nulls. Pattern 5. The Outbox Pattern. You have 2 systems during migration. Events need to reach both without dual write inconsistency. Pattern 6. Circuit Breaker. Protect the legacy system while new services are still stabilized. Pattern 7. Event-driven Final Decoupling. The last synchronous dependency cut by an async event stream. These patterns compound. Each one removes a constraint that was blocking the next. By the end, you have a FastAPI fleet that owns the business logic and a monolith that handles nothing. Let me start with why teams fail at this before we talk about how to succeed. The monolith calcifies because of fear. Circular dependencies make it possible to change one module without breaking 3 others. Nobody has a complete map of the dependency graph. It lives in people's head, and those people leave. Static analysis tools help, but they still require a developer to interpret the output and make decisions. The Big Bang rewrite has a near-perfect failure rate scale. You write a new system in parallel, you diverge from the moving target of production, you never fully cut over, and you end up with maintaining both forever. What changes with agentic workflow is the economics of the exploratory work. The part that blocks teams is not the writing of the new FastAPI code. It is the analysis phase. Which modules can be safely extracted first? Which tables are shared across domain boundaries? Which endpoints are entry point versus internal helpers? This is the work that Claude Code can do in minutes instead of weeks. The approach I use, Claude Code does the dependency scanning and candidate selection. I make the architectural decisions. Claude Code generates the scaffold. I review and own the out. The speed up is real, but so is the principle. Agentic automation accelerates the judgment. It does not replace it. Pattern 1 is the Strangler Fig, and it is the foundation every other pattern in this video builds on. The idea is simple. You do not rewrite the monolith. You wrap it. You put a routing facade in front of it, an API gateway or a simple reverse proxy, and you redirect the traffic to the new FastAPI services one endpoint at a time. The monolith still handles whatever you have not migrated yet. The new service owns what you have successfully extracted. Gradually, the monolith handles less and less until you can shut it off. The hard part is choosing where to start. The wrong entry point costs you 6 weeks before you discover that this module touches 40 tables and has no clean boundary. The right entry point is a module with minimal shared state, few callers, and a well-defined contract. Here's where Claude Code earns its place. I give it the code base and ask it to generate a dependency graph, which modules import, which database tables each module owns or touches, which modules have no reverse dependencies. Those are the extractions candidates. Claude Code maps this in a single session that would take senior developer 3 days manually. Step 1. Claude Code scans the code base and produce a ranked extraction candidate list. Step 2. I review the candidates and select the target module. Architecture is my decision, not the models. Step 3. Claude Code generates the FastAPI router, the Pydantic request and the response models, and the routing rule in the facade that redirects traffic from the monolith to the new service. The result is a working FastAPI service with a clean boundary scaffolded from the monolith's existing logic in a fraction of a time. 2 patterns that run in parallel with the Strangler Fig. The API Gateway Facade is the routing layer that makes the Strangler Fig possible without clients knowing a migration is happening. Every request goes through the gateway. The gateway routes to the monolith for anything not yet migrated and to the FastAPI fleet for anything that is. SSL termination, authentication validation, and rate limiting happen at the gateway before the request reaches either system. Claude Code's role here is generating routing configuration, Nginx roadblocks, NOC plugin, config, or an AWS API gateway open API spec. You describe the split and it produces the routing rules. The sidecar pattern solves a related problem. When you extract a module, you also need to extract its cross-cutting concerns. Logging format, distributed trace injection, authentication token validation. If each FastAPI service reimplements these, you get inconsistency. The sidecar patterns move these concerns into a lightweight proxy that runs alongside the service. The service talks its sidecar, the sidecar handles the cross-cutting work. In Kubernetes, this is a second container in the same pod. In Docker Compose, it's a companion container on the same network. Envoy, Nginx, and Linkerd are common sidecars implementations. Claude Code generates the sidecar container definition and the middleware configuration. The cross-cutting logic stays outside the service boundary. Pattern 4 is where Claude Code has the highest leverage in the real migration. The legacy schemas are archaeological artifacts. Column names that made sense in 2015, nullable strings where business logic knows it must be populated, integer IDs where the domain uses UUIDs, varchar 255 where you mean an email address. This schema encodes technical depth from every developer who was in a rush. Pydantic models enforce the contract you actually want. Type annotations, validators, alias mapping, field constraints. The boundary between your FastAPI service and the outside world becomes explicit and machine checkable. The gap between the legacy schema and the Pydantic model is where data corruption lives during a migration. A nullable column that the old code handled with an implicit default will produce a validation error in the new service. You need to find every one of these gaps before hit the production. Claude Code does this translation automatically. You give the legacy DDL, the create table statements, and ask it to produce Pydantic request and response model with field validators, alias mapping for snake case to camel case conversion, and explicit optional annotations for any nullable columns. It also flags the semantic ambiguities. A column called status of the type of integer with a no foreign key constraint and no check constraints. Claude Code will note that and ask you clarify the domain meaning. The output is a Pydantic model you run on. The time saving is the initial translations, not removing the review step. During migration, you have two systems in running simultaneously. Both systems need to stay in sync. This is the dual write problem, and it is the source of more silent data corruption than almost anything else in a migration. The naive approach: write the new service database, then publish an event to the broker, then let the legacy system consume the event. Two writes. A network failure between them leaves the system inconsistent. You wrote the database, but event never reached the broker. The legacy system never got update. The Outbox pattern solves this at the database level. You write your domain change and event record in the same database transaction. Both succeeded or both failed automatically. A separate Outbox publisher process reads uncommitted events from the Outbox table and forwards them to the broker. Only once the broker acknowledges does the publisher mark the event processed. The result: your service never produces a domain change without corresponding event because they are the same transaction. The broker gets events because the publisher retries until acknowledged. Claude Code generates the Outbox table DDL, the publisher service code, and the FastAPI endpoint modification that's at the Outbox write. The pattern is boilerplate once you understand it. Agentic generation is here, genius time save. During a dual system migration, new services fail. They are new code. They have edge cases the monolith handled by accident for years. Without protection, a new service failure cascades back to the legacy system and takes it down too. The circuit breaker is the protection layer. It monitors the failure rate of calls from legacy to the new service. When failures exceeded the threshold, the circuits open. Calls fail fast without reaching the new service. The legacy system falls back on its own implementation for those roles. After a timeout, the circuit enters half open. One probe request goes through. If it succeeded, the circuit closes. If it fails, it reopens. 3 states: closed, request passed through normally; open, fail fast, no call made; half open, one probe, then close or reopen. The migration context makes this especially important. The circuit breaker is not just a resilience pattern here. It's a safety net for the migration itself. A bad deployment to the new service does not break the production monolith. The legacy fallback path stays warm until the new service is confirmed stable. Resilience 4G, Poly, and Hystrix are common implementations. FastAPI with Tenacity handles retree logic. The circuit breaker configuration is boilerplate. Claude Code can generate for your specific failure threshold and timeout requirements. Patterns 1 through 6 extract the easy and medium modules. They leave you with the hard 20%. The core business logic that tightly coupled, deeply shared, and has the most side effects. Getting the last synchronous dependency out of the monolith requires a different technique. Event-driven decoupling is how you cut the last direct call. Instead of the legacy system calling the new service synchronously, the legacy system publishes a domain event. Order placed, for example, payment processed, event inventory reserved, something like that. The new FastAPI service subscribes and reacts asynchronously. The direct call is gone. The dependency is now through the broker, not through the network. This is also how you achieve the full Strangler Fig completion. The monolith stops handling business logic and starts handling only events it still owns. One by one, you migrate those events produced to FastAPI services. When the last event producer is migrated, the monolith has nothing left to do. The broker is Kafka for high throughput durable streams, or AWS Event Bridge, for example, for managed event routing. FastAPI consumers use background tasks or separate worker processes. The key design requirement is idempotent consumers. Events will be delivered at least once. The same event processed twice must produce the same result. Claude Code generates the producer event definition, the FastAPI consumer handler, and the idempotency key implementation. Pattern 7 is the completion of the migration, not an addition to it. Let me make the agentic workflow concrete. Across all 7 patterns, Claude Code pays the same 4 roles. Analyze, read the code base, map imports, identify shared tables, flag circular dependencies, rank extraction candidates by risk. The output will be a structured dependency report. Second, map. Translate the analysis into a migration action plan. Which module to extract in this sprint? Which Pydantic model it needs? Which table it owns versus shares? The output will be an extraction brief. Then generate. Scaffold the implementation, FastAPI router, Pydantic models, routing facade rule, Outbox table, Sidecar configuration, circuit breaker setup. The output will be working code for review. Next step will be validation. Validate. Run the existing test suite against the new service. Compare the schema contracts. Check routing coverage. Every endpoint that has handled by the monolith has corresponding FastAPI route. The output will be coverage report and contract differential. You review and own a route. The automation is in the mechanical translation work, not in the architectural decisions. The decisions, which module to extract, what Pydantic contract should be, where the circuit breaker threshold sits, those stay with you. This 4-step loops repeats for every module extraction. The first iteration takes longer because you are getting up the tooling. By the third extraction, you are running this loop under an hour. Here is the full migration structured as 4 phases. Phase 1, week 1 to 4. Foundation, stand up the Gateway API facade in front of the monolith. Zero traffic has moved yet. Identify the extraction candidates using Claude Code's dependency analysis. Extract the first module using the Strangler Fig. Validate its staging. The monolith handles everything except the extracted module. Phase 2, weeks 5 to 8. Sidecar and schema. Deploy the Sidecar proxies to the extracted services. Translate all legacy schemas for the target module into Pydantic model, of course using with Claude Code. Implement the Outbox pattern for any module that publishes events. Extract 2 or 3 modules. That's it. Move to phase 3, weeks 9 to 12. Circuit breakers and stabilizations. Instrument all calls between legacy and new services with circuit breakers. Run load tests with intentional new service failures to verify legacy fallback paths. Complete extraction of medium risk modules. That's it. Phase 4, weeks 13 plus, wherever it goes. Event-driven final decoupling. Migrate core business logic to event-driven FastAPI consumers. Cut it remaining synchronous dependencies. Decommission the monolith routes one by one. Final validation. Monolith is shut down now. The principle all across 4 phases. Never create the legacy. Never create the next legacy. Again and again. Each FastAPI service has a strict Pydantic boundary, an outbox for all the main events, a circuit breaker on all downstream calls, and a sidecar for cross-cutting concerns. The architecture you build now should not need migration in 5 years. That is the 7 patterns: Strangler Fig, API Gateway Facade, Sidecar, Schema-First with Pydantic, Outbox, Circuit Breaker, Event-Driven Final Decoupling. The through line, Claude Code compresses the mechanical analysis and scaffold generation. You keep the architectural decisions. The migration moves at the speed of judgment, not the speed of typing. The GitHub repository with the sample legacy app and 7 pattern implementation is linked in the description. If this was useful, subscribe more senior engineering content, and if you are currently running a migration and want a second opinion on your extraction strategy, my Upwork profile is in the description too. See you in the next one. Please don't forget subscribe and like this video. Thank you.